Okay, so this is just more examples with simplifying and solving rational expressions, mainly the simplifying part. The ones we're going to solve here are pretty simple. So can you guys help me with this first problem? What should I do first?
Factor the...
You could, of course, start by factoring all the tops and bottoms first. That's a great idea. I'm just going to do something else first, though, because I don't have a lot of space. You know what I mean? I see a few hands going like that. Now remember, sometimes this might look like it'd be underneath here. It means the same thing. Either way, you got to multiply by the reciprocal. So you guys have it written down. What was on the bottom? I don't know.
7x plus 77.
And then the other one was?
2x plus 8.
Thank you. All right, so now we can do all the factoring stuff. So let's see. This guy on top is a pretty easy one, right? What's that factor into? 4 and 5, isn't it? Yeah. Minus 5 plus 4, okay. Can we factor this guy on top at all? I'm just going to go in one thing, right? Because I multiply fractions across the top and the bottom. Anything there?
Take out 7. Take out 7.
X.
Plus 11.
Okay. Anything there?
You can take out 2. X. 4.
How about this one?
5. I got a 5.
Yep, they all do share 5. Otherwise, you'd have to do that long process. These are huge numbers, so that wouldn't be pretty. So 5 and...
X squared plus 6x minus 55.
Use your calculator, and that was what?
55.
55? Okay, so I'm just going to chop some stuff. Well, there's not a lot I can chop yet. So this guy, I'm going to say, what are some factors of 55?
5 and 11.
5 and 11 is like all about it besides 55 and 1, right? Is that per chance going to work?
Yeah,
I engineered it to work. So it's going to be what? Just plus 11 or plus 5?
Plus 11.
Plus 11 if you want positive 6. So it's going to be, again, not advisable to erase, but I don't have a lot of room. So plus 11 minus 5. And some stuff cancels. Because it was built to. Now when you do this in the real world, in the wild, if you will, stuff might not always cancel. So some of your problems might not have a whole lot that cancels, and that's okay. But here, quite a bit of stuff canceled, didn't it? Oh, yeah, I made most of it. So 7 on top. And 10 on the bottom? Everything canceled?
Yeah.
Wild. So what you're telling me is this is just equal to a horizontal line, y equals 7/10, like a horizontal line not quite 1 high? As a graph, yes. We're going to start graphing these soon. But this horizontal line has some funky stuff in it because it's undefined in some places.
So it's not like little section.
That's a great question. Maybe there's some parts of this line that have been cut out. I think that's a great guess. We'll see. We'll see if Courtney's right next week. But at -4, something weird. At 5, something weird. At -11, something weird. Otherwise, it's just going to be a little flat line. Okay? So, let's erase that guy and have a look at a couple equations. So, we'll start with a pretty simple one. I think this one might be in one of my other videos, but couldn't think of another one in time. It's an equation, it's not an expression, right? So we're not just simplifying, we're trying to find x. Is there anything when you're looking at it you just feel like you're inclined to do? Hopefully you see the top over there and you're like, I just want to factor that.
Positive 5.
Positive 5.
Negative 2.
-2, does that work? Yeah. Okay, so that's going to be all over x minus 2, and we're supposed to set it equal to 7. But I see a minus, John. Danger, Will Robinson. Is it okay to cancel or not? Because we could think about this with its own little set of parentheses, and it's really just a product. So yes, but careful, right? So yes, it's okay to cancel that and get x plus 5 equals 7.
And then that's easy.
So that says x equals 2, right? Just subtract 5 or just think about it. Okay, so 2 is the only answer there, right?
No.
When we were doing radical equations last week, we had these things that sometimes occurred that weren't actually solutions. What were those? They were called extraneous, but you know, that's what they were. This is an extraneous answer. Why? Now, like I said, you don't have to be real monotonous about this and like always plug your answer all the way in and check everything. I'll show you one where we can do that today.
It's over 0.
But you should just be like, look back at the thing. If I put it there,
2 is 0.
I divide by 0, and that's something that's not possible. In fact, if you put this in your calculator, whatever shape this has will never cross 7. There's no solution to this problem. So that might happen, so be on the alert for extraneous solutions. Does it take a lot of work to see if they're extraneous for these? No, you're just like, look. And you're like, wow, that makes the bottom 0. It's probably not an answer. I'm done. Okay? So, let's do another equation before we do something else. Oh, wait, I think we'll do another equation in a sec. I've got one ready to go here. I wanted to ask you guys about this. This is having to do with the algebraic mistakes of infamy. At least one of those contains mistakes. You guys tell me what's good or what's bad about them. There's 3 different ones, right? Anna, you see something?
On A, you just went straight into doing 1/4, and they're not products, they're adding and subtracting.
Yeah, there's adding and subtracting here, but I was like, I see an x squared on the top and I see one on the bottom. I'm just going to completely ignore PEMDAS, which says I have to like do, you know, tops and bottoms first or inside parentheses first. And I was just like, nah, I'm going to do that.
That's not
Yeah,
right.
yeah. That's 1, right? It's terrible. Sorry I exposed you to that, Travis. Lindsay?
See, you're just everything to a half like you would a regular fraction. But no. Because you have a plus there, plus 2 messes up everything at the end.
You're still talking about the last one though, right?
C.
Oh, she's talking about C, so you think C is wrong? What do you guys think? Yeah?
Wouldn't it be 6x squared on top?
Because, like, why?
Because he's asking what the top and bottom share. So
So you're thinking about factoring, like, with what they share? I agree. So should we just, like, try to do the problem ourselves and see what happens? So the top is the top, right? So it's just what it is. The bottom, I agree, they share something. What is that?
2.
2.
You don't want to play the what they share game between the top and the bottom. Does that make sense? If they share stuff between the top and the bottom, you can just cancel it out. But you can't do that here because of that, right? But you can say these guys share it too. What's left?
3x squared plus 1 plus
Take the 2 out of the 2, you get 1. Remember, when I say take out of, I mean division, right? So, is that?
No.
Product, one thing. Can you go 12 divided by 2 now?
Yes.
And what's 12 divided by 2?
6.
And where should I put the 6? On the top or the bottom? Oh,
Oh.
so that's all right. And then, in fact, that's fully reduced. I thought that might tempt you guys to think something was wrong, but it's not. That's fully reduced on that problem. Alana?
I think B is wrong because when you tried to cancel out the x before factoring you said
And then I was like, what's left? Well, like, stuff cancels because it's 1. Yeah. So I was like, well, I better throw a 1 somewhere. Here, though, or here? I don't know there. But why can't I do that? Once again, there's a subtraction here. I don't have any kind of product going on. Now, if I had something like this, if I had x over x times stuff, then I have a product, so yeah, I can go like that and say 1 over that stuff. But I can't do it on that situation we just had, okay? Now, if you like Jolly Ranchers and Rainbows, it's pretty easy to see that concept. If like this was something much more ugly looking, it's the same concept, so don't get intimidated. Okay, last problem we're going to do so you guys can have some time to work on your problems, because you've got a lot, is this one. I thought that we didn't do one kind of factoring yesterday. We should probably review. Something we should know in Algebra 2. This one might not make you like jump out of your seat and try to factor it right away, but you can factor it. What is that top thing?
You can do like a cube root thing, right?
Yeah, you can do the sum of cubes. So let's remind ourselves about this factoring scheme. The sum of cubes, if you have something cubed plus something else cubed, how does that go? I think it goes like this. You guys should know this in Algebra 2. I mean, I even showed my Algebra 1 students this last year. So x plus, you start with the thing that it says, and then if you just use common sense, you don't have to use a whole lot of memorization here if you've done this and have a little experience. So I think x squared times x will be x cubed. What should I put here? W squared, because then that times that's w cubed. The only part that's a little iffy is the middle, so I just remember there's one of each. And then the signs go plus, each one of them has one minus for the cubic formulas. So plus, minus, plus. Each one of the cubic formulas has one minus. So we can factor this guy like that. So what's being cubed in that first spot right there? 3 and x. So 3x is like x up here, okay? So we've got 3x. What's being cubed to make 64? Alg2. I start it with plus. And then I say, okay, if you want to equate it to what I wrote up there, for us, x is 3x. And for us, w is 4. So then I do x squared, which is going to be 9x squared. I do w squared, which is going to be 16. And I do xw, which is 12x plus minus plus. That's factored. There's the rest of it. I heard something. Can I cancel? But there's a plus. This is a whole piece, and we've really got multiplication going on here. So yes, we can cancel. We get this parabola left equals 4. I think we know how to solve parabolas. We've been using the bread and butter technique all day yesterday and today. Factoring. I bet this one doesn't factor though. That 4 is going to mess it up. Because what do I have to do first?
Set it to 0.
Yeah, so I need to move that 4. Say 9x squared minus 12x minus 4 minus 4 is 12. Now you could play this game. Try to factor this guy. I'm just going to cut the chase and tell you it doesn't work because, I don't know, maybe it works. Maybe I won the lottery today because when I made up this equation, I made this up in my head. I put that on the bottom so it'd cancel nicely for you guys. And then I put a random number over here. So unless I had been very choosy about this random number, I don't think it's going to factor. Let's find out. So what else could we use if the factoring fails? Quadratic formula, we could do that. I'm going to do something else just to remind you have that option. Machine. So I'm going to go to my machine for this one and we'll see what happens. So you guys should follow along because you definitely need to know how to do this. Very important. You got to know this for everything after this class. So let's stick this guy and have our calculator do all the hard work. So I'm not putting the original problem in, I'm just putting this little parabola we got to deal with here, right? And seeing how many zeros it has and all that stuff. So let's see, I'm going to go 9x squared is 12x plus 12, and then I'm going to hit zoom 6 because this is an equation. Ah, I see a little thing. If you zoom out a little bit, you'll see it better. So what does that let me say?
It has imaginary.
Yeah, if we use the quadratic formula, we'd get the imaginary answers, but we don't care about those today. So we're going to say no real solution. I was kind of hoping that we'd get an answer. We can get an answer somehow. Let's change the problem. That one would have no real solution, though.
Scary.
Let's pick another number that might make that parabola drop down and have solutions so we can review how to do this. Give me a thing to put over here that might help. What? I heard a minus. That sounds good because our parabola is up too high. Maybe if we like subtract enough, it'll like somehow drop it down. You know what I'm saying? Should we go like a... I don't know if that's going to be enough. We can find out. If not, we'll fix it again. So add 20.
36.
Oh, is that going to work? Because really that's like adding more. So we can try it. We'll try it one more time. And maybe I'm thinking wrong, but so that makes this be 36. Oh, if I can type. 36. I'm even already zoomed out now and I can't see it. If I zoom out more. See, if you just hit zoom out, it like zooms out in every dimension and that's hard to see. So I like to go and mess with my window. Also something you guys need to start practicing. You need to get better with your calculators. Notice it still has only imaginary answers. So negative 20 was not a very good call. I want this to be negative. How am I going to get that to be negative?
Positive 20.
Should make this be positive 20 maybe? That's barely going to make it negative here. Let's make it even more.
50.
Alright, we'll go 40 or 50. So if that's 50, then 16 minus 50 is going to be... Maybe that'll drop our parabola down. Don't you guys wish you could always just make your math assignment do this?
Just do what we want to.
Ah, now I can see them. I just went back to Zoom standard. So let's calculate them. Remember, tracing them is not good enough. We want a lot of accuracy here, a lot of precision. So I'm going to hit second, calculate what? I'm trying to find zeros. So I'm going to go left. There, I can see it. That's on the left. Right. I don't have a lot of choices. I'm going to go more down. It's down there. And now as close as I could get was right here. So here we go. So I'm going to say my answers to this guy are x equals approximately negative 1.388. And the other one's going to be, I don't know, 2 something looks like. 2.7? Give me more decimals. 2.1. You sure? You guys have backing her up? 2.721? Let's see if she's right. So I'm going to actually check this one. Here we go, out to the home screen. Now you don't have to do this on all your problems, but of course you should be thinking that I could, if I had to. If my life depended on it. Someone has a gun to my head. I could check this answer if I really had to. So I'm going to stick this back into the very beginning. In fact, where did the very beginning of ours go? What was it? Wasn't it? So I'm going to put it in the very beginning and say, okay, 27, I'm going to get a nice fraction going. Here we go. 27 times, we're going to check that one, right? Cubed. Plus 64 over 3 times 2.721 plus 4. And what is it supposed to tell me if this is actually an answer? Exactly 50? What do you guys think? Around 50. It's not going to be perfect because I chopped it off and made it approximate, right? So here we go. That's the right answer. Yep. All right. So if you want more examples, just have a look at my videos. See you next time.